Hi there, my name is Dylan McVay and I'm in field marketing here at Universal Robots. We're here at Automate in our booth showcasing our physical AI demos with all of our partners. We'd like to see what our first partner here is demoing, Vention here. And so I'm going to speak with Jeremy and he's going to explain what this demo is doing here.
Awesome, sweet. So hi, my name is Jeremy. I'm a user education lead at Benton, and this demo that I'm showcasing over here is the Rapid Operator AI. It's a physical AI application, and the specific one is showcasing an unstructured picking application, which can primarily be used, say, for machine tending. For how it works, the system is able to take a photo of parts in an unstructured manner, identify which one it's looking to pick up, and automatically plan its path on how to pick it up and place it in the final destination. Now, this entire cell was designed on Vention's platform, so it can be customized to really fit any client's need. But the technical problems that this really solves in the industry is, first, normally unstructured bin picking is a very costly and very complicated process. But Vention, in partnership with NVIDIA, has created a low-cost solution that is able to be deployed on many operators' shop floor. And the second is that this allows operators to upskill themselves and be moved to more important roles within their industry, as opposed to doing simple tasks such as pick and place applications for machine tending. If you're curious about anything else, you can check out our website at vention.com.
Thank you, Jeremy. And we'll go on to our next demo over here and speak with our AI trainer group and see what they're up to. And now we're here with Ika, and we're going to talk to Baptiste to explain to us what his demo is showcasing today.
So thanks, Dylan. So my name is Baptiste Bush. I'm co-founder of Ika, and it's a software company that specializes in what we call force control and sensitive control. The idea behind it is when you have applications like polishing, you want to apply a constant force on the piece during the process. And that needs to be regulated through what we call a force sensor here that is on the robots. And this allows us really to, you see like here, control the robots to maintain a constant pressure no matter what happens, if I pull it off or if it like the pieces here were done. And this is really crucial for a lot of applications, polishing, deburring, sanding, or also assembly that we show quite often. So we have a specialty also in gearbox assembly that we did for a client in Germany.
Next subject matter expert. So now we're here at Generalist. I'm speaking with Joseph, and he's going to explain what their demo is showcasing in our booth today.
All right, hi. So Generalist, we are premiering our foundation model called Gen 1 that we released this year. It's pre-trained on 500,000 hours of real-world manipulation data. And what we're demonstrating with this task today is a couple of things. One is dexterous moments that our model can handle. So once you use our foundation model, you fine-tune on top of it, and you get high levels of performance, even with really dexterous tasks like dealing with single-use cardboard that we basically have been abusing now for a few days at the conference. And this task is basically, we send a visual signal to the robot, it's time to work. I want you to assemble a box, pack these bolts, and then put it in the outgoing bin. And what's really kind of unique about this demo is what we call the physical improvisation moments, which is things don't go as planned, the world is messy, these boxes, they don't always insert the way you want them to. So instead of getting stuck in a loop of doing the same manipulation over and over again and not getting a different outcome, the model will change its path, come up with another solution to try to get the flap to go in, to get the bolts into the box, and to carry it across the workspace.
Awesome, thanks, Joseph.
Cheers.
And subject matter expert over here at Trener. And now we're here with Trener. I'm going to speak with Andrew to explain what they're showcasing in our booth today.
All right, thank you. We have a language model interface to help operators of machines quickly program jobs for robots. So all they need to do is come into our front end and describe what part they want to machine, the dimensions pre and post machining. And once they put in all the parameters, our system takes those parameters and turns them into the robot motions you see happening here with the robot doing a machine tending task, where it's loading parts into our CNC machine, taking them to one operation, flipping the part, and going to a second operation. So all the user needs to do to make sure that this task works well is define the part dimensions, the geometry of the part pre and post machining, which operations they want the robot to do, whether they want it to do additional blow-off steps to clear the vise, whether it wants to do inspection steps, and then they activate that cell once they're ready and they confirm the parameters. They can also mention what kind of work pieces they need to do. They can come back and edit the job, and it's all done with plain language, just ChatGPT style conversation with our front-end agent.
Awesome. Well, thank you, Andrew, for walking us through that. Let's go ahead and check out our next partner over here. Good. Now we're here at our AI trainer demo, and I'm going to speak with Brett from UR and Tim with Scale to explain what's happening and what they're showcasing here in our booth.
Hi, I'm Brett, and this is our AI trainer cell. And what we're showing here is a full turnkey AI training cell that'll soon be available. We're showing our teleoperation bit. So what we're showing here is two UR3 arms that are used as input devices to teleoperate these two UR7Es. We have full control and haptic feedback. As I bump into these tables, I can feel them. We're preventing protective stops with our new control algorithms that are now available. So what I'm showing here is an admittance controller that allows me to feel the force, and then an impedance controller on the follower arms that allow us to do things like make contact with objects on the table, not protective stop. So you can see here how soft and compliant our arm is. This is enabled by our new direct torque control API and our impedance controller built on top of that. Our teleoperation software is running on Polyscope X, our latest and greatest operating system, which has full Dockerization to run software in Docker containers, as well as a full web-based HMI that allows us to do things like render the camera feeds on our Teach pendant. And we're using this to collect data to train models with the Scale software. And I'll hand it off to Tim.
Yeah, so my name is Tim. I work at Scale AI. We've partnered with Universal Robots here to integrate our robotics intelligence suite with the UR AI trainer. So this software allows the user to control the robot, collect data of them accomplishing a task, take that data, bring it into our development platform to train a model, and then deploy that model back on the same robot to evaluate its performance. So this end-to-end process allows our customers at R&D labs to experiment with physical AI and really get to know their models, their data, and build effective automations for the business.